So now we want to look at how we find the length of a line. Now here on the graph to the left of your screen, we have a line whose endpoints are 1, 5 and 5, 2. And we're asked to find the length of the line. Now of course you could always use a rule and measure it. Right? But we want to use coordinate geometry. So we want to calculate the length of the line without actually measuring the actual line. Now, suppose you did not know the formula to calculate the length of this line. Let's say you did not have a formula to calculate this length of the line. Can you think of a way you can find the length of this line without actually using a ruler to measure this line? Let me give you a hint. Pythagoras theorem. What if you form a triangle, a right angle triangle, like this, and then, so you form a right angle triangle like that. Could you now calculate the length of the line? Let's do it using Pythagoras theorem. Let's call the length of this line, let's call it, what should I call it? Let's call it x. Let's call the length of this line x. But remember what Pythagoras theorem says? The hypotenuse square. So the x would be the hypotenuse square. Would be equal to the sum of the squares of the other two sides. So this side was the length of this side. How many squares do we have here? 1, 2, 3 square. So the length of this side here is, this height of the triangle here is 3 units. Agree? So 3 square. And then the base of this triangle, how many units? 1, 2, 3, 4. So 4 square. So the height of this triangle is, and the base is 4. So x squared equals 3 squared plus 4 squared. So x squared would be equal to 9 plus 16. And x squared is 9 plus 16. 25. So x is the square root of 25, which is 5. So this, the length of this side here, the hypotenuse side, would be 5 units. So we know the length of this line is 5, based on Pythagoras theorem. Let us look at the formula that is normally given to us now. Alright? So formula says x, well, formula is now given as length, RD. Alright, let me write length, RD, which is represent the same thing that x represent. So the formula is given as this. Which is x2 minus x1 all square, so square root of x2 minus x1 square, plus y2 minus y1 all square. So that's the official formula in coordinate geometry for the length of the line. I just want you to realize that this formula comes directly from Pythagoras theorem. Alright, let's actually use a formula to find the length of this line and see if we get the same 5. So the length. Now before we go on, let's label x1 and x2. Let's label x1 and x2. Which one you want to call x1? Which x value you want to call x1? Let me call this x1. Which means this would have to be y1. And let me call this x2. Which means the other value would have to be y2. So use the formula. x2 minus x1 squared. So x2, so what are the x values? 5 and 1. Just observe what the 5 minus 1 give you. 5 minus 1 square. So x2 minus x1. x2 is 5, x1 is 1. And 5 minus 1, what it actually gives you is the length of the base of the triangle here. Give you a length of of the base of the triangle here, which you realize this will be 4. So it's actually 4 square we have in here. Alright? So this formula is taken directly from Pythagoras theorem, because this side square and then y2 minus y1. Let's look at what y2 minus y1 is. y2 minus y1. This is y2. y2 is 2. And y1 is 5. So it's 2 minus 5. That's 2 minus 5. Negative 3. But we talk about distances. Distances can only be positive, right? Because distances are scalar. So distances, direction does not matter. But negative 3, you're going to square it anyway. So you still get 9. Alright? So L is square root of 5 minus 1. So 4 square. Plus 2 minus 5 is minus 3 square. And if you remember how we looked at it just now, the length of this line we found to be 4, and we found this to be 3. And if you notice, still Pythagoras theorem we're using. Because if you should square both sides, what you'll have is L square, we call it L, is L square equal to 4 square plus 3 square. Alright, so it's directly taken from Pythagoras theorem. So L is square root of 16 plus 9. And what's 16 plus 9? 25. So L is the square root of 25. So you want to call it L, LRX. It doesn't matter what you want to call it. Just LRX, right? Alright. So L is the square root of 25, which means it's 5 units. Good. So the length of this line is actually 5 units, just as if you had used Pythagoras theorem. Because what does Pythagoras says? X square or L square, the hypotenuse side square, equal the sum of the squares of the other two sides. Right? Which is exactly what this is. And what you'll have is x squared equal 25, because what? This is 9 plus 16, right? Same thing here. X square root of 25. Alright, so the exact same thing. So this is the official formula that we are given. Alright, but just recognize that this formula is directly taken from or derived from Pythagoras theorem. Let's do one more example using the formula.